One of the key objectives of the 2Cs programme was to exploit the high potential for technological innovation in the 2Cs area by developing new technologies, products and services to generate an impact on key sectors of shared interest identified in the region's smart specialisation strategies. This would help stakeholders better tackle important societal challenges such as in the fields of health and well-being, demographic change, food security, sustainable agriculture, or clean energy, to name a few. Through technological and applied research and investments, the ultimate goal was to increase the maturity of technologies from their validation in lab, also known as Technology Readiness Level 3, to their demonstration in an operational environment at TRL 7, and to enable the joint economic exploitation of innovations. A total of 187 project partners participated in 18 projects, receiving just over 51 million euros to fund their activities around sectors as varied as healthcare, environmental and marine technologies, agro-food, smart manufacturing, and transport and ports. In practice, these projects delivered prototypes, pilot and demonstration actions, and feasibility studies. One example of a standout prototype is this obstacle alerting system for electric wheelchairs from the project EduCat. In this project, 6 partners collaborated to develop a connected wheelchair with a will to place the user at the centre of the design process. The connected wheelchair collects a multitude of data, such as joystick movements and driving profiles. It is also equipped with various sensors, such as positional sensors, GPS, inertial measurement unit and distance sensors, infrared and ultrasound. Advancing the offshore renewable energy sector, Encore explored novel methods to exploit tidal, wave and solar power with 4 innovative pilots. A biomimetic tidal energy converter, transforming kinetic energy into electricity. A floating solar power panel adapted to harsh, high-wave offshore conditions. A fully submerged wave energy system converting wave motion into water pressure. And a vertical axis water turbine that generates energy from low-velocity water flows. The project thereby fostered technological progress, commercial viability, and sustainable development in related industries. There is also this revolutionary demonstrator from E2C, which facilitated the scaling up of the conversion of CO2 into other products, such as dimethyl ether, or DME for short. This can be used as a replacement for diesel or liquefied natural gas, or used as a chemical in plastics, as explained by these project researchers.
If you combine CO2 and hydrogen, then we produce DME and water, and by taking out the water with the absorbance material, we force it into the production of DME. So the amount is that high that it's a valuable product.
The good thing is that we can transport the reactor and pilot as well, which means that we can also try this for testing at industrial sites.
And make it a kind of plug and play in the industry.
And the next step would be coupling it to green hydrogen, which we'll do in the field lab for industrial electrification in Rotterdam. That can help us move towards a more circular carbon economy.
Projects have contributed to a variety of extremely positive results, such as increased skills and capacities, namely via scientific publications, technological transfer, patent filing, and new forms of cooperation and partnerships to increase the uptake of these innovations, improved health and living conditions, and increased business capacity. With technological transfer, the project H4DC produced a variety of devices and methods which reduced the impact of the Cryptosporidium parasite in cattle farming. This extremely common pathogen can lead to significant economic losses for livestock farms. However, thanks to the outreach work done by the H4DC project, more than 200 farmers were introduced to the project technologies. This will help farming communities throughout the 2Cs area to combat the dangers posed by this parasite. When it comes to paving the way for improved health and living conditions, let's hear the testimony of a study participant testing the powered ankle-foot orthosis. This is a prototype developed by the Motion Project to help people with cerebral palsy be more independent and have an enhanced quality of life.
En mijn kant die dat verlamd is, via een motor dat aan een spalk verbonden is, hebben ze mij geholpen met mijn voet op en neer te zetten. Ik had gekozen om mee te doen met het onderzoek om deze mensen vooruit te helpen dat dit organiseren. En ja, ik denk wel dat het hun erg vooruit helpt voor in de toekomst andere mensen, nog meer mensen zoals mij te helpen.
Speaking of technology transfer and new forms of cooperation and partnerships, the MOTION project continued its work with the later ReHome project as part of the Interreg Northwest Europe programme. Finally, for increased business capacity, Qualify has produced novel guidelines for the certification of adhesively bonded hybrid joints in primary structures in marine environment. They enabled wider adoption of adhesively bonded composite to metal joints by the maritime transport industry, which subsequently massively decreased fuel consumption, leading to both carbon emission and cost savings. Other sectors, such as the offshore wind industry, could also benefit from greatly reduced maintenance costs. Overall, with this objective, 2C stakeholders made significant achievements with technological transfer and the scaling up of tests and pilots, accompanied by enhanced cooperation between key actors throughout the innovation chain. If you are interested in finding out more about what these projects have achieved, or if you are interested in creating synergies with other 2Cs initiatives, then check out the output library on the Interreg 2Cs website.